Hello everyone, today we are going to take next lecture on dual nature of radiation and matter. Okay, in previous lecture we have studied about the photocell. What is photocell? Photocell again works on the principle of photoelectric effect, and this photocell generate photo current, and this photocell is used in different phenomena, or in different ways we can use this photocell. That is, it used as a counter in malls and anywhere, that is as a counter. Then again it is used as a alarm. Okay, again it is used in street light ऑन ऑफ करण्यासाठी यूज करतो. पुन्हा स्ट्रीटचे जे काय लॉज आहेत ते लॉज कोण ब्रेक करत असेल तर ते डिटेक्ट करण्यासाठी सुद्धा आपण फोटोसेलचा यूज करतो. बरोबर, हे सगळं आपण लास्ट लेक्चरमध्ये बघितलेलं आहे. नेक्स्ट इज द डी ब्रोग्लीज हायपोथेसिस. व्हॉट इज अ डी ब्रोग्लीज hypothesis? Okay, we know that the light or any radiation or matter which has dual nature, that is particle nature, and second one is the wave nature. It consists of dual nature, that is particle nature and wave nature. Sometimes that light radiation or matter act as a particle, or sometimes it act as a wave. Okay, but this de Broglie showed, or in this de Broglie hypothesis we are going to discuss that a matter or a radiation has a dual nature, that is both particle as well as wave nature. Okay, according to the Einstein's famous equation, that is E is equal to mc square. Okay, we know that E is equal to mc square. This is the Einstein's famous equation. Okay, then from this equation we can write mc into c, that is c square can be that mc into c. Then m into c म्हणजे mass into velocity gives the momentum. Therefore this can be written as pc, that is E energy is equal to p into c. Okay, then again according to that energy of photon is equal to h into nu. Okay, h nu, where h is the Planck constant and nu is the frequency of that radiation. And using this equation, in above equation we can write h into nu is equal to pc, and therefore this p, that is momentum, is equal to p is equal to h nu divided by c, and therefore this momentum p is equal to h, and nu divided by c म्हणजेच काय, तर it is equal to 1 upon lambda. Therefore p is equal to h divided by lambda, and therefore this lambda is equal to h divided by p. This is called as the de Broglie's relation. Okay, this is called as the de Broglie's wavelength or de Broglie's equation. Okay, in that this momentum p is again is equal to m into v. Therefore we can write this lambda is equal to h divided by m into v. Then when a particle is moving, or radiation or matter is moving with velocity v, then we can write lambda is equal to h upon m into v. This is known as de Broglie's wavelength. Okay, again for a particle of mass m moving with velocity v, particle of mass m moving with velocity v, we can write it has a kinetic energy, and that kinetic energy ek is equal to half m into v square. Okay, from this equation we can write v square is equal to this m upon 2 is on this side, that is ek into 2 divided by m. Therefore v is equal to square root twice ek divided by m. This equation gives the velocity of that particle which is moving, velocity of particle. Okay, then using this velocity of particle in the de Broglie's relation, that is lambda is equal to h divided by m into v, that is square root of twice ek divided by m. Okay, then it is equal to h divided by m can be written as square root of m into square root of m. Okay, into this is square root of m divided by square root of twice ek. Understand? Then next, this lambda is equal to square root of m get cancelled and h divided by square root of twice ek into m, that is twice m into ek. This equation again gives the wavelength in terms of kinetic energy. Okay, then for a charged particle, if that particle is a charged particle with charge q and the potential difference is v, then we can write the kinetic energy or we can write the work done by that particle, charged particle. That work done w is equal to charge into the potential, and therefore this work done can be equal to the kinetic energy of that particle. Therefore this ek is also equal to q into v, and therefore lambda is equal to काय मिळेल h divided by square root of twice m into q into v. This equation gives the wavelength for a particle. Again see, in this relation किंवा हे आपण सगळं बघितलं काय आहे, फेमस आइन्स्टाईनचं इक्वेशन कन्सिडर केलं. आइन्स्टाईनच्या इक्वेशनमध्ये आपण फोटॉनची एनर्जी यूज केली आणि फोटॉनची एनर्जी यूज केल्यानंतर आपण काय काढलेलं आहे, तर लॅम्बडा इज इक्वल टू एच अपॉन पी, अँड दॅट इक्वेशन इज कॉल्ड एज द डी ब्रोग्लीज इक्वेशन, और दिस इज कॉल्ड एज द लॅम्बडा इज द डी ब्रोग्लीज वेवलेंथ. ओके, then this de Broglie's wavelength it shows किंवा this equation shows the particle and wave nature of that matter or radiation. How? See, here it is lambda. Lambda means wavelength of particle or wavelength of that radiation. Okay, then as there is a wavelength means, what is mean by wavelength? Which is related to wave. Wavelength means it is related to wave nature of that radiation. Okay, therefore this lambda shows the wave nature of particle, wave nature of radiation. Okay, similarly here it is a term of momentum. What is mean by momentum? See, आपण एखादा दगड जर आपण एखाद्या वस्तूकडे फेकला तर ती वस्तू डॅमेज होणार आहे. कधी होणार आहे, तर त्या जो काय आपण ऑब्जेक्ट फेकणार आहे किंवा दगड फेकणार आहे त्या दगडला मोमेंटम असेल तर ती समोरची वस्तू काय होईल, डॅमेज होईल. आणि मग मोमेंटम आहे म्हणजेच काय, दॅट इज द पार्टिकल. आपण पार्टिकल असेल तरच तो बंबार्ड करू शकतो. therefore this momentum shows the particle nature of that material or that matter. Therefore matter has wave nature and particle nature simultaneously, which can be shown by this de Broglie's hypothesis or de Broglie's relation wavelength, that is lambda is equal to h upon p, and that is equal to lambda is equal to h upon mv. And then again it has a kinetic energy, therefore we are using that kinetic energy, and then we get the equation lambda is equal to h upon square root twice m q into v. अंडरस्टँड? इथपर्यंत समजलं. नेक्स्ट बघा, आता हे जे रिलेशन आहे या रिलेशनवरून आपण एक इलेक्ट्रॉन कन्सिडर केला. दिस रिलेशन इज होल्ड good for any charged particle like photon, electron, etc. Okay, then for electron, see what is that equation, lambda is equal to h divided by square root of twice m into q into potential v. Okay, see, for electron, there is a charged particle called as electron. For electron we can write this lambda as c. This lambda is equal to h divided by square root of twice m e, that is mass of electron, and q is the mass of electron E and then potential V. Okay, then we know the H, that is the Planck constant. Value of Planck constant is 6.625 into 10 raised to minus 34 joule second. It is equal to joule second. Okay, then mass of electron. What is the mass of electron? It is 9.1 into 10 raised to minus 31 kg. Okay, then next is the charge. Charge on electron, it is 1.6 into 10 raised to minus 19 coulomb. Okay, this is the charge on electron, and by using all these equation, in this equation we get, after calculating this, lambda is equal to 1.228 into 10 raised to minus 9 divided by square root of V. This is in meter. This wavelength is in meter. Okay. By using all this term in this lambda, then we get lambda is equal to 1.228 into 10 raised to minus 9 divided by square root of V meter. Okay. In a nanometer, we can write it as nanometer, that is lambda is equal to 1.228 divided by square root of V nanometer. This is the wavelength for a electron. Okay, understand? This is all about the de Broglie's hypothesis and de Broglie's relation. Okay, understand? Thank you.